Hey, welcome to the new podcast. Today I'm trying something different. I'm playing a little bit of like retro cafe music on the background to give some kind of a vibe to this pod. I don't know how it will be, but let's see. It's just an experiment. So today it will be a very quick podcast. I am not going to share much progress on what I'm building. I just want to share that things are moving in the forward direction, but not as fast as we hoped. There are a lot of tasks which are pending, and I'm also managing that another Mac app which is being built. So most of my time is going into that. But yeah, things are going good. The only thing which I wanted to share today in this pod, and I was super excited because I heard this news today that Meta is being sued for snooping on Snapchat's traffic. Now, as soon as I read that, and I was like, how is that possible? Like Snapchat is a completely different entity, a completely different company app, which is owned by, they have their own servers. And then I thought maybe Snapchat is using Facebook ads, and that's how the traffic is being snooped. But I highly doubt like Snapchat would use their competitors, the number one competitors ad, and they would want to share this data with them. So then I got a bit more interested, like what's happening behind the scene. And the story was super interesting to me. It was so exciting that I couldn't wait to make a video on this. So let's go and check it out what happened. So basically, recently, Facebook is again, they have revealed some documents, internal documents, where they have found that Facebook was snooping on the data of users, of US users, for the traffic to Snapchat, of YouTube, and Amazon. So these three companies were, the data from these companies was snooped by Facebook. How is it possible? Because most of it is being done with the mobile app, with the iOS or Android. We already know, like being an Android and iOS developer myself, I know it's not possible with, normally it's not possible. Like you cannot see, any of the other app cannot see what's the other app is doing, basically. The app A and app B have no correlation in between the data which is being sent. I would love to explain it in using some like documents here, right? So let's suppose if you install an app and we call it Facebook. It's too big. So if you install Facebook and then you install WhatsApp and then you install Snapchat and then you install YouTube, and let's say this is WhatsApp and this is YouTube and this is Snapchat. Now, whenever you are working on Facebook, right? So all the data which you are, like you call, you see your user profile, right? This is a API call which is going. Then you also see your timeline where you see all the posts, and then also you see like friend requests. So these are all the API calls which are made to Facebook server. And let's say, or maybe we can check in library. No, let's not do that. So all this data goes into Facebook, or we can call it Meta server, right? Because they own the whole database. So all these requests are going back to Facebook and coming back to Facebook. This is what happens when you're using these apps in your mobile phone. Similarly, if you're using WhatsApp, all this data goes from WhatsApp as well, but WhatsApp is owned by Facebook. So technically it's going to the Meta server. So they have all this access, right? They can correlate with Facebook's data to WhatsApp's data. Like for example, if I'm a kind of person who sends a lot of GIF, and so the WhatsApp team can share this data to the Facebook team internally, and they can tweak their UI specifically for me or users like me, where the GIF button is always on the front of my app. Companies do this a lot. They gather all this data to make their product much better. So this is completely fine. Like Facebook, WhatsApp, both are owned by the same company. So they do share a lot of data to each other, and they can basically know everything about what you are doing in these two different apps. But here the case is very, very different. In this case, this is like a Snapchat server. So anytime you talk to the Snapchat server, you are making a call from whenever you are using Snapchat, you're making a call to Snapchat. There is no meta server involved, right? And then the data can come back to you right here. And so all the communication happening is between Snapchat and server and your mobile app via internet. This is what happens. Facebook has no idea what you are doing inside Snapchat. Similarly, when you're talking about YouTube, let's say, when you're talking about YouTube, all the data, all the video requests you're making, all the buttons you're clicking, all the data is going to YouTube. This is how apps are like have their own isolated environments inside a mobile app. So no other app can know what you are doing inside another app. That's how the fundamental or the basic OS works. So this was very interesting to me. I was so interested to know how can Facebook know about Snapchat's data? How they did this basically. And the trick is really interesting. So what Facebook was doing basically. So Facebook bought a company called as, I've written it down somewhere. It's called Onavo. So Onavo is a VPN service. So if you do not know about VPN, let's clean it up. So how VPN works, let's say how VPN works, right? So what you do when you are in your mobile app, you talk to any server, A server, B server. These are all like, let's say this is a Google server and this is YouTube, which is X, and this is Facebook, right? This is Facebook server. So all these are servers managed by these companies. And when you make these requests go via an ISP. ISP is your internet service provider. So you make a call. So basically, like for example, your ISP is Airtel. You make a request, Airtel takes your request, Airtel passes this request and to a Google server. It knows where it wants to go. And then you make another request. ISP says, okay, the request is going to YouTube and the request is transferred. But ISPs or your ISPs or your Wi-Fi network cannot know what you are transferring, because there is an SSL security certificate which is installed. So as WhatsApp also promotes this a lot, like all your data is encrypted, because there is a client side certificate which you can think of as a key. So there is a key here in your client. So this key is like, let's say this is a Facebook key. Only Facebook creates this key on your server, on your client, and then Facebook creates this key on their server. So whenever you are transferring this data, nobody can read it in the middle unless it unlocks with this key. And the decryption happens with this key and the encryption happens with this key. This key remains inside Facebook's app in your phone, and this key remains in Facebook server when it's going to Facebook server. So there is no middle attack can happen because nobody knows about this key. Similarly, when they say about the end-to-end encryption, when you send a message from Facebook to WhatsApp to another WhatsApp user, that goes via Facebook server, but even Facebook doesn't know about that key, because the key then is in the other client's user. That's called like end-to-end encryption. So for example, if you're sending a message to your friend, it's been encrypted with, let's say this is another key, which is a WhatsApp key. So WhatsApp locks the message, decrypts it, and then it transfers the message to your ISP. ISP sends it to, well, technically WhatsApp server, which is owned by Facebook. So Facebook server, Facebook doesn't know because Facebook has no key. And then Facebook transfers that decrypted message to your friend, and your friend has a key specifically created for you. So whenever you open your WhatsApp, you see a yellow error message, not error, like a warning message that, yeah, this is message chat is encrypted end to end. And then with that key, which is like WhatsApp key friend one. So WhatsApp, every friend has its own key, and WhatsApp then, when you sign it from here, it unsigned here on the other end. This is how generally encryption and decryption works, and this is how the data which we pass or do in our activities we do in our mobile phone via internet are secure, and we 100% rely on them. And this is the thing which makes us like hack proof. So nobody can hack us because nobody can see what we are sending messages, and this is what internet privacy looks like. Now there comes a concept of VPN. So what happens is sometimes some companies, or wait, let me just see if this is all recording. Yeah, it's all recording, fine. So what happens, sometimes you use a VPN network because you do not want to even let your ISP know what you are going to do. So giving you a basic example, let's suppose TikTok is banned in India, right? So if you try to open a TikTok, let's say here is TikTok. This is TikTok server. So whenever you make a request to your ISP, hey, I want to see this TikTok ISP, I want to talk to TikTok, can you give me? So it will not send the request here. It will just block it for you because ISP knows the government of India has blocked it. So I will not pass this request to TikTok. Here comes the concept of VPN. What VPN will do, VPN will come in the middle here somewhere. Right. Now, what VPN will do, when you send your request to your ISP, the VPN client is here. You install a VPN client. Let's say this is your VPN client, which is installed in your system, in your mobile phone. Now VPN client, when it's running, it will take all your requests. It has only the VPN client has this permission that it can know all the data which you are trying to send, and it can manipulate that data because you have given this permission to it. And so you have to trust the VPN client now. So what you say, hey, I want to open TikTok. So it will take that request and it will send this request to its own server. So VPNs have their own servers. Let's say this is the VPN server. And this server could be in, let's say it's in Singapore. So what VPN will do, the client will send a request to its own server. So basically ISP cannot block it because ISP thinks, okay, this request is going to a VPN server. And VPN then will pass this request to TikTok. TikTok will then reply back to the VPN server, and then VPN server will reply to your ISP, and then you will get the data. So you are bypassing all the data from a VPN server to your client. This becomes super interesting. Now you can bypass anything from your client. So this is kind of like man in the middle, because a VPN server sits in the middle and manages all your requests. And they can block, for example, if you are trying to access any website which is globally known as illegal, so VPN can block it. Or not just illegal, but let's say it's malicious. It can download a virus into your system. It can harm you. So VPNs can provide the security that they block those kind of connections. So they keep themselves up to date wherever ISPs do not really care about until the government is into the play. So ISP is ruled by governments, but VPNs ruled by their own like private entities. So they can provide you this kind of security, but not mandatory. You have to just trust that the VPN is doing the right job and it will keep your data secure. Now, why we are talking about all this is because this is what the concept of hacking, we can say, Facebook used. So what Facebook did, they bought this company called Onavo. Here it's mentioned in the TechCrunch, this one, in 2013. It's an Israeli-based company. And now if you own Onavo, a VPN-based company, and millions of users are already using it in US, so technically the VPN server is now belongs to Facebook. So Facebook owns this VPN server. So all the traffic which is going from this mobile is now bypassing via Facebook only. So if you're using Snapchat in this case, then you are not directly calling Snapchat. You are technically calling a VPN server here. It sits in the middle, which is owned by Facebook. So now Facebook can read everything going on, but still, like as we talked about here, right? Facebook cannot read because all the data is encrypted. So encryption plays a key role. What Facebook did here, They went one step ahead to read all the data. They did not just install the VPN server, they also installed a client side certificate, which then takes all your request, sends that data to Facebook decrypts it, and then bypasses it to Snapchat. So Facebook is creating these client certificates to fool Snapchat servers that it is coming from a real client, and taking all the requests which is coming from Snapchat client to send the data and decrypt it on their server. So that's how they knew what's happening on Snapchat, what's happening on YouTube, on these devices, and what's happening on Amazon, like where users are clicking. And one interesting thing I noted was there was this app called To Be Honest app. Yeah, there's a wiki page for this app. So this app was created by Nikita Beer, and Facebook bought this app immediately. Like once this app was launched, it was on the top charts, and this was very famous with youngsters. Even a lot of tech community was not sure why Facebook is buying it, because this app was built like in a weekend. It has like 2-3 pages. It was very basic app, nothing complex in this, no tech complexities. But what happened was none of the company would buy this. Like if I had like $1 billion and I just see, okay, this app is ranking higher, and I would not go buy this app. But Facebook was interested in, because they have all this data. They were snooping the users like requests. So they knew this new server is coming up, and a lot of requests for this To Be Honest is coming to their servers on this because of this snooping. And this is why they were so interested to know what this app is doing so different, and why this is so popular. So they bought the app immediately because they felt like it's a threat. So you understand, like because of the data they were gathering from these Snoop devices, they were able to make this decision to buy that app and just shut it down immediately, and maybe implement those features in their own servers, in their own apps, basically. So this is again so interesting, right? Interesting in terms of like engineering, which went behind all to do all this, but the legality of doing this is insane. If I do this right now, I would be called as a cyber criminal, and I would be behind the bars. It's a severe crime to do this. Severe crime. There are crazy laws in US, crazy laws even in India. So, but what Facebook is dealing right now, they just have given a penalty of some compensation they have to pay, and that's it. They're free. And so this is why Facebook would be interested in like the data from YouTube or Snapchat, right? So Facebook, let's say Snapchat has released a new feature which is called Reels or Stories. Well, technically Facebook stole the Stories idea. Now, if you see Stories, what is the best way to gather the data? Like how many users are using this Stories feature? Either people are talking in online about it, in forums about it, and you yourself like talking to a lot of people around you. But this is not a real data you can like really feel confident to build it yourself or implement it in your app. You really need a real tangible data which is coming from a true source. And what true source is good than Snapchat itself? So whenever all these apps implement these analytics frameworks. So Snapchat would have these analytics framework where whenever user is clicking on stories or adding a story, they would send a event to their own server. So they know how many stories are being uploaded in a day, how many users are clicking on the plus button. So they can adjust the button's position to make their product better, as I discussed earlier. Similarly, Facebook is now snooping all this data. So Facebook knows how many times a user is coming to the app and clicking on this plus button and adding the story. So now they can implement this feature in their app. They can do the exactly same things which Snapchat has done without doing these experiment by themselves. So they can just see the data, implement it themselves, which reduces their research a lot, which increases their time to market, and it's just a win-win. So in my opinion, Facebook has done these tactics from a long time, and that's why people say never bet against Mark Zuckerberg, because he knows all these black hat tactics to gather data and to make the best decisions. And you can only make good decisions if you have the best data set available in front of you. So yeah, I don't know how do you feel about it, but for me, this whole concept of hacking or snooping by Facebook was super interesting how they did it. And if you are using any VPN server, well, in general, as a user, I don't think you have to worry about anything. The only thing you have to worry about it if they have decrypted your chats, so those chats are not secure anymore. If the client is snooped on your side and Facebook is getting all these messages, so Facebook is reading all your messages right now, and anybody can read it. So this is called as a man in the middle attack. So do not install such certificates in your device. Just use a VPN server, but do not install the certificates which can install these like client-side certificates in your system, so your messages can be decrypted. And yeah, I think that's about it. This is a quick episode, as I said, and maybe I'll make another video tomorrow. This is a weekend. It's 30th March and it's a Saturday. Did a lot of work today since morning, and I was reading this news, got super hyped to create this video to share what I learned about this whole hacking by Facebook. And if you have any questions, any doubt on how this all works, so basically I have given a very brief or abstract version of how these things work. There is a lot of internal tech which goes behind everything, like how the VPN server, how the client SSL certificate snooping, there's Wireshark and super illegal stuff, which Facebook has already done. And the tech is super interesting. And yeah. Again, thank you so much for listening to this pod. I will be coming up in the next episode. Thank you so much. Bye-bye.